Hello everyone, this is Dr. Rajesh and I am again back with you with my next video lecture on the topic subgroups. In the last video lecture, we have studied the necessary and sufficient condition for a non-empty set H to be subgroup of G. So that condition was important and that condition will be used here. So we will be studying an important theorem and the statement of the theorem is given as if H1 and H2 are two subgroups of G, then H1 intersection H2 is also subgroup of G. This is a very important theorem from examination point of view. Proof. So let us suppose that H1 and H2 are two subgroups of G. Let us suppose that H1 and H2 are two subgroups of G. Required to prove H1 intersection H2 is also a subgroup of G. Okay, so that we require to prove. So if we say that H1 and H2 are having the element common in H1 and H2, if I say H1 is subgroup, this implies that H1 has having identity element. Similarly, H2 is subgroup. This also guarantees that identity is always unique. It cannot be different. That is the property. So it is also having the identity element. This implies that identity element goes in both intersection. In common also, like this is H1, this is H2. So this identity element and say this whole total is G. Identity element is in the common. So this implies that H1 intersection H2 has at least one element, that is guaranteed. If it is having at least element, if I say that H1 intersection H2 is not equal to empty set, this implies that H1 intersection H2 is non-empty because identity element will be there. Next we will prove that it is subset of G. So for that, since H1 and H2 are subgroups of G, this implies that H1 is subset of G, H2 is also subset of G, because if they are subgroups they will also be subsets, and intersection of two subsets is also subsets. This implies that H1 intersection H2 is a subset of G and it is also non-empty. So now we are in a position to use the last result that we have proved that for a non-empty subset of G, that condition, necessary and sufficient condition to be subgroup is that if A belonging to H, B belonging to H, then this implies that A, B inverse should belong to H. For the same purpose, we will take if A belonging to H1 intersection H2 and B belonging to H1 intersection H2, we will prove that A B inverse belonging to H1 intersection H2. So let A belonging to H1 intersection H2 and B is also belonging to H1 intersection H2. This implies that AB belongs to H1 intersection, both A and B are in H1 intersection H2, elements of H1 intersection H2. This implies that A and B both belongs to H1 intersection, means it is in both. So AB belongs to H2. But it is given that H1 is subgroup. So if A and B belong, then A B inverse will also belong to H1, and H2 is also subgroup. So A B inverse will also belongs to H2. This implies that, yeah, you will write, since H1 and H2 are subgroups of G, therefore AB inverse belongs to H1 and AB inverse belongs to H2. If it is belonging to H1 also and it is also belonging to H2, so it will go into the intersection also. This implies that AB inverse belong to H1 intersection H2. So we have proved that if A and B are belonging to H1 intersection H2, then AB inverse belongs to H1 intersection H2. Therefore, H1 intersection H2 is subgroup of G. So we have proved that if there are two subgroups H1 and H2, then their intersection H1 intersection H2 is also subgroup. So if we say that intersection of two subgroups is again a subgroup, we have proved that result, and the result used in proving this is this one. So we have studied it earlier. This is the result used in this particular theorem, and we have already proved that a necessary and sufficient condition for a non-empty subset H of group G. That is why firstly we have proved that H1 and intersection H2 is having identity element, and there that guarantees that this is non-empty. Then we proved that H1 intersection H2 is subset. Only then we will be in a position to use that particular theorem. So we assumed AB belongs to H1 intersection H2, then proved that AB must belong to. So this is the necessary and sufficient condition that we have used to prove the given result. So in this video lecture, we have proved that the intersection of two subgroups is again a subgroup. So this is all I have from this lecture. If you have liked the lecture, please like, subscribe, share and comment. And your comments in the comment section are always valued, welcomed and appreciated. And if you have any query, you could raise that in the comment section. So this is Dr. Rajesh saying you goodbye, take care, bye bye.